Today I'll give a presentation regarding oleogel application in foods, giving insights on what we have been doing in the food processing group at INL. So the title of my presentation, as you can see, is Oleogels as a Strategy for Fat Replacement and Food Fortification. So, as you all know, nowadays society is facing increasing challenges, namely some related to food consumption, of course. I have highlighted three of them: health and well-being, pinpointing to obesity, diabetes, and hypertension, which are diseases associated to fat consumption. Another point is sustainability, as we must target food waste reduction and also decrease our dependence of petrol-based plastics. And the final one is regarding aging and urbanization, as trends by the consumer are now focusing on convenience food, personalization foods, and these are all based in emotion as well. So, okay. As pointed before, diet-related diseases must be addressed. As we can see, the percentage of obese people is rising, and so is the rise of cardiovascular diseases like diabetes as well, and also cancer diseases. The data from the European Society of Cardiology says that 1 in 5 Europeans are obese, so this is a concern and we must address this. So, are we able to remove fats from everyday food? We need to promote substitution of trans and saturated fats in food products. We need to maintain properties, so we need to make this replacement of fat without altering food perception, sensibility, and taste by the consumer. And we need to be innovative, so we need to find new formulations that are able to enhance nutritional value and food structure as well. So are the oleogels or organogels the solution, or one of the solutions? So why oleogels? Oleogels are composed by edible liquid phase that is entrapped in a structurant network. They can be solid-like, and they have a continuous structure with macroscopic dimensions. They can be tailored to mimic characteristics of the traditional used fats. They can also provide solid-like properties to food while reducing the levels of saturated fatty acids. This is a very important parameter because we really need to address the use of hydrogenated fats as well as saturated ones, while promoting the use of unsaturated fatty acids that are placed in edible oils like olive oil and other vegetable oils that are liquid at room temperature, and we are able to induce a solid-like structure using oleogelators. So a brief overview, we can see that the interest from the scientific community in organogels or oleogels has been increasing in the past years, and this leads also to the interest from the food industry as well. There are some gelator sources that can be selected to induce oil structuring, as well as different vegetable oils that can suit the final application, and we can select them as well. So I can highlight some of them. Regarding the gelators, we can select waxes like beeswax, for example, polysaccharides like ethyl cellulose, protein sources, surfactants like lecithin and monosterates, and also low molecular organogelators like phytosterols. Regarding methodologies, we can highlight two distinct procedures for oleogel productions, namely direct gelation and indirect gelation. this can also be addressed as direct dispersion of gelators and indirect dispersion. This method, the first method, consists in the direct dispersion of the oleogelator or gelator in liquid oil. This is done at high temperature, so we need to perform this in temperatures above the melting point of the gelator, and is followed by a cooling period where a three-dimensional network will be responsible for the oil entrapment and consequent oleogel formation. So using this approach, the gelation mechanism can originate from both crystalline conformations and also self-assemble tubular ones, for instance. Regarding beeswax-based oleogels, our former investigations allowed us to understand the tailoring ability of these gels. The increasing concentration allowed us to modify the melting temperatures of these gels. We can see that the thermoreversibility and thixotropy is there as well. These are very interesting gelators because waxes are able to induce oil gelation using very low percentage of gelator. So we are able to use very low amounts of solids in order to produce oleogels. Likewise, monosterate-based oleogels, we are able to produce oleogels with very low concentrations of both glyceryl monosterate or sorbitol monosterate. As you can see, as we increase the concentration of these components, the structural network increases, as well as the rheological and or viscoelastic properties. Regarding still in the direct dispersion approach, here I will focus on sterol-based oleogels. These oleogels are very interesting because they are formed by an interconnection of two molecules, gamma oryzanol and beta sitosterol. These sterols dock on top of each other and they form nanostructured tubules that will be able to induce oil gelation. This particular oleogels, this combination of these two components, when promoted in the right amount, and this I'm saying a correct ratio and proper concentration, will allow to develop gels that are quite transparent and that reveal increased hardness. So this tubular conformation is very consistent through time. We investigated these gels using small angle X-ray and Raman spectra, confocal Raman spectroscopy, and we are able to understand that apart from the beeswax-based or monosterate-based oleogels, these gels do not, they are not just dependent from temperature. So we have to induce the cool down procedure. We have to bring the gels from liquid form to in high temperature to low temperature, but there is a time dependence of these gels. So we can have very cold gels that are not still solid. There is a time-dependent factor here. And we can see that the increase of gelator concentration will also promote the development of more harder gels, and also with oil migration, with different oil migration profiles. As we decrease the concentration of gelator, the oil migration percentage increases with time, and this could be a very interesting point in terms of digestion, as well as the delivery of bioactives. Regarding bioactives, we also studied the incorporation of a model compound lipophilic model compound, beta-carotene in beeswax-based oleogels. So the fortification of this structure is a very important step for us, as the incorporation of bioactives can enlarge the application of these structures in foods. Here, the incorporation of this beta-carotene, we were able to understand the oxidative profile of these beeswax-based gels, and we were able to understand that since we surpass the critical point of gelation, when we have where we have solid-like gels, the oxidative stability was higher. So in the sense that beta-carotene was less exposed to the environmental conditions and was therefore more protected by the gelator network. Still on the fortification of gels, we moved to the digestion behavior of these gels. We use the InfoGest protocol, and we understand how the micellar of the lipid phase occurred with these structures. So we understood that lipid particles migration towards the aqueous phase was happening at different rates. Here I give the example of beeswax-based gels, but we also tested this with the sterol-based ones. And this happened because of the action of bile salts and phospholipids, were key intervenients in the which are key intervenients in the digestion of lipids, as they are responsible for the formation of the mixed micelles that then will lead to the bioactives to be absorbed at the intestinal level. Here, a brief remark on the indirect dispersion approach of developing organogels or oleogels. This allowed for the possibility to develop oleogel-based systems from structured emulsion templates. So using monostrates or sterols, we were able to produce solid-like structures that are able to be fortified with both lipophilic and hydrophilic bioactive compounds. This is very interesting and important for us because it widens the field of application of these types of structures, and this is very important for us going forward. Regarding the application in food products, we were able to test the incorporation of oleogels in different formulations. We were able to produce hamburgers using sterol-based oleogels. Also, using sterol-based oleogels, we were able to produce sausages, smoked sausages. And with pate and frankfurters, we were able to promote the incorporation of beeswax oleogels. Here I'm giving the example of hamburgers that we developed using linseed oil as the base for oleogel production. So we promoted the substitution, the two-level substitution of fats, and with the substitution of 25% and 75% of the saturated fat fraction from the control from the regular or control hamburger, we are able to understand what was the texture profile of these hamburgers, and we were also able to understand that the nutritional profile was quite changed because we used linseed oil to produce the oleogels. Therefore, we had an increase in the linolenic, alpha-linolenic fatty acid. So we were able to promote the incorporation of unsaturated fatty acid with high content of omega-3. So this is very good for us because we were able to understand that this fatty acid profile was maintained, and the acceptance and the preference results also showed that the consumers were able to select the intermediate substitution, so the 25% saturated fat substitution as a desired formulation. So globally the samples were rated different, but for some parameters like the visual aspect, the juiciness and tenderness, the control was very comparable with the H25 samples. The other example that I give here, and the last one, I will give only examples of hamburgers and pâtés. We selected beeswax-based oleogels, also using linseed oil, to be selected to a new formulation of liver pâté. And the results were quite promising as well, because the relation, we can establish a relation between the amount of the linseed oil, which has a very strong scent, a very strong aroma, a fishy one, so sometimes not desirable for the consumers, but the intermediate formulation, the 30% substitution, scored very acceptable for us regarding the flavor and texture. So some of the panelists also selected this one as one of the preferred ones, and we were also able to understand that the nutritional profile was maintained after the processing of the thermal processing of the pâté, and we were also able to introduce high amounts of omega-3 in this formulation. So I will give you final remarks. It's possible to improve the fatty acid profile of tested food products without changing most of the textural parameters that were evaluated. The tests that we performed with hamburgers, some also with pâté, show that consumer acceptance and preference was directed towards the control samples. However, there were some very interesting and positive feedback regarding the substitution formulations, or the ones that we introduced oleogels as fat substitutes. Omega-3 intake potential is increased with this technology, and also tailoring properties must be further explored in order to close this gap that I've mentioned in terms of consumer preference. I will also like to thank you for listening to me, and I'll leave you with two remarks. Right now, this oleogel technology is being applied in 2 funded projects at INL. These projects are also with companies, with the industry, and these are Better Fat for Meat, which is based in the development of structured fat to use in meat products as a substitution of animal fat. And the other one is Ice Care Project, which is based in the formulation of cardio-healthy functional ice creams. Thank you.
Thank you very much, Artur. Very, very nice presentation. So we have now some minutes for questions.
I just want to say that I received a message that we have 10 minutes left. I don't know why. I thought that this meeting was without any restriction of time, but I think I will have to create another, I need to create another link that I will send to you all in order to resume in 10 minutes.
Okay, please do that, because otherwise we need to hear as well Laura. So questions?
Hello, Artur.
Hi.
This is Juscelino speaking here. It's very interesting information you have provided. And I wonder if you have any idea of how the formation of these type of structures can influence the bioavailability of the fat, how the fat will be digested and absorbed.
Mm-hmm.
Do you have any information regarding that?
Yeah, we performed some tests regarding lipolysis as well.
Yeah.
So depending on the concentration and the type of structure that we are producing, or the gelators that we use to form the oleogels, this will vary. So
Okay.
we are still in this stage of studying the digestion of these structures.
Okay.
The tests that we performed with the wax-based gels showed that we had increased bioavailability when we compared with the regular oil, just an oil phase, but it's a very, very small increase. So probably some of the steps that we are performing during the digestion can help us to understand a little bit what's going on and how we can improve these results.
Okay. Yeah, it's interesting. Especially, I was thinking about the formation of the complexes with polar lipids like lecithin, because we are interested now in what glycolipids can do for metabolic responses to fat.
Yeah.
And I guess whatever you are doing is also a very interesting field. If you can manipulate or modulate the triglyceridemia, postprandial triglyceridemia by complexing these kind of things, it will be a very interesting way of working.
We performed some tests, not in this matter of digestion, but just producing oleogels with the lecithin. But as you know, lecithin needs some polar phase, like water, in order to form micelles.
Yes.
So we can do suspensions without water, but in order to promote structuring using lecithin, we'll need to have water, and that will probably increase the availability at the intestinal level of the gels, of course.
Yeah, Juscelino, this is a very interesting topic. Sure. And it's a little bit tricky. We did some experiments regarding digestion of this kind of structures, and we obtained some results that are not evident at all at the beginning. So some behaviors, because some different behaviors happens during the formation of the mixed micelles. When you are dealing with structured fats, or if you are dealing with free normal fats, so normal oil. So, but this is quite complicated. So it's important to have this information for or to perform these experiments for each kind of fats, because there are not a direct correlation between the behavior of a particular structure during a particular lipid structure during the digestion. It's not so direct.
No, yeah, definitely, and that's why I was asking, because we can see differences in metabolic responses if you exchange part of the fat by this polar lipid-rich material, but then the molecular explanation for that is far away from us. But we see differences in metabolic responses, which is the part that is interesting. There might be a chance for cooperating in that sense.
Absolutely, because actually we are studying this kind at microscopic level. And not only microscopic, but as well at molecular level, what are these changes in the structure during the digestion? And this is important. We have a colleague in our team, which is Katarina, and they are trying to study this in the next step in a gut-on-a-chip model. So in order to mimic the gastrointestinal tract and to perform different trials at the same time in parallel, because it's quite complicated to perform these digestion trials. I take advantage of this point because we have 3 minutes left in this meeting. So Artur, are you sending us the new link?
I will leave here on Zoom on the chat.
Okay.
Okay. So we're going to do a break for connecting again. When Artur send us the link. So in this chat or by mail, Artur?
In this chat, yeah. Then you can just copy paste. I don't know. Probably it will be faster.
Okay, good. Good. Next speaker will be Laura Principato. I have scheduled a meeting with our director general. So I cannot skip this meeting in 30 minutes. So probably I will leave the seminar before the seminar finishing. But please keep in the seminar, ask questions, comments, whatever.
So I'm sending it now.
In the chat, so I'm not seeing the chat. Okay, okay, good. So we have the new.
And I'm so sorry. I don't know why this is happening.
Okay, we have the new how do you say, the new link in the chat. So in 1 minute we will be back. Okay.
See you then.
Okay, see you.
Ya está.
Hello, hello again. Hello everyone. Well, I don't know if there are more questions for Artur. If not, we can pass to Laura. Laura, are you here?
Yes, can you hear me?
Okay, the floor is yours.
Okay, perfect. I will share my screen. I will share my face, first of all. Hello to everyone. And then I will share my screen. Okay. Can you see this? Okay.
Nice. Go ahead.
May I don't know if it's moving. Wait,
No, it's
okay.
fine. It's fine. It's fine. We're watching your screen. Yeah.
But I'm not, okay, yes, now yes. Okay, I was just checking. Okay, good day, everyone. I'm Laura Principato. I'm here to basically to link this presentation for the thing that Artur says before me. In the introduction part, you will hear some repetition, but it's good because the topic is new. I will discuss about oleogel as an innovative replacement for saturated food, fat in food products. Here there is an overview of the main topics that we will cover. First of all, we will try to give a brief definition of what is an oleogel, how oleogel is placed in the new food trends, and what researcher has already done as the inclusion of oleogel in food system. Then we will focus on the wax oleogel that Artur has already introduced in a brilliant way. And I will show you a case study of a system made with a kind of waxes, the rice grain waxes, that was fortified with the inclusion of dietary fiber. And then we will move at the end for the conclusion. First of all, what is oleogel? Oleogel is a complex system that is made mainly by a large portion of liquid oil. Usually it's more than 90%. And with the use of one or more gelling agents, you can change the physical states of the edible oil from a liquid to solid or semi-solid, depending on the kind of gelling agent and also the kind of technology that you are using. What are the main benefits that oleogel has? It's a physical process, so avoid the drawback of the common structuring chemical enzymatic treatment, like the production of trans and hydrogenated fatty acids. So on the other hand, it preserves the original nutritional profile of the oil. Meanwhile, it texturizes the oil structure. Oleogel is placed in many food trends, but one of them, if we think to the key trends of 2020, is the fat reborn. There are two trends related to one, to the demonization of the fats, and then the integration of the so-called healthy fat inside the human diet. Nowadays, customers has getting more and more awareness about their lifestyle, their nutritional choices, and also because they are paying attention on the nutritional aspect, especially with the food and food fat, and also because the market gives them the possibility to have a lot of alternatives that are available. But for products that usually contain saturated fat, this opens up a lot of challenges, because food industries need to reformulate their products to hear and to comply with the voice of customers. But the product that they want to reformulate also to satisfy other requirements, regulatory requirements, technological and sensorial requirements that are really important on the final accessibility of the product. And finally, also the market sustainability. So why oleogel? It's a potential solution. Oleogel, the gelling agents that make possible this transition are main. They are classified by the nature, by this kind of classification by the nature, by the techniques. Here are reported basically what's also Artur reported, basically by the technique divided by the direct dispersion and the indirect use. But the thing that you can modulate both the gelling agent selection and both the process parameter, to control the process parameters, helps you to design the microstructure that gives you different macro thermal and mechanical properties at thermal level, at macroscopic level. And so at the end, you can obtain different products with different functionality. Here are the main three groups in which the researcher and the academia is putting some effort about the inclusion of oleogel in food system. They are basically divided in bakery, meat-based system, and emulsion and creams. Among all the gelling systems that are available now, I want to focus on the use of wax oleogel. And why? Why? Because wax oleogel are direct dispersive gelling agents that they crystallize in a thermal cycle in which they are heated up at the melting temperature, and then they are cooled down, and during the cooling there is the formation of a three-dimensional network that entraps the oil inside and create and change the states of the oil from liquids to gels. They are a very potential gelling agent because you can use it at a very low concentration, and according to the kind of the properties of the waxes that are divided by low melting and high melting waxes. You can also create mixed system with the targeted final properties. They are approved by EFSA, FDA. Most of them, there is the shellac that is still not, but the other, yes, are both approved for food inclusion. And because of the very easy way to handle this process are at the moment the easiest to scale up. Of course, there are some drawbacks. There are a strong dependency of the waxes with the oil activity that completely change the final properties and the texture of your product, of your network, and there is a full affinity with the lipolytic substances in food matrix that can, in a system that contains water, and a lot of food that contains water, can create some instability. What I'm going to show you is part of our initial research, because I'm not a postdoc. I just want to clarify that I'm a PhD student, and this is a work that we made, but of course the pandemic has a role in our results, but we obtain a lot of useful outcomes. What we made, we selected the ribrim wax as natural wax, and we obtain oleogel. We produce oleogel evaluating the oil type, selecting two kinds of oil, sunflower and olive oil, the wax concentration using two concentration 4.5 and 5.5, the cooling temperature using 25, 4 and 0 degrees. And also we added some dietary fiber. We select some bamboo fiber at 0.% weight at 3 different granulometries, 40, 90 and 150. The inclusion of fiber was related, our hypothesis was to reinforce our network with the inclusion of the fiber. Then the system that were tested and the more relevant system were used for the complete substitution of butter in cookie preparation. Okay, here there is briefly scheme of what we have done. We mixed up the rice grain wax with the oils and with and without the fiber. We taken up until 18 degrees, and then we cool down at the 3 different temperatures that I mentioned before. We obtain the gel that were then analyzed. Considering all those parameters that we have taken into account, 48 systems were obtained. They were analyzed based on rheology, color, texture, and differential scan calorimetry. What about this? As we said before, oleogel is a complex system. Here are the viscosity curve of our system. In particular, we have the viscosity curve of oleogel made with and without bamboo fiber at 40 microns, both in both oil, so sunflower and Evo, at different temperature and at different wax concentration. As you can see, the straight line that is in the bottom of each figure represents the viscosity of the oil itself. It is basically a Newtonian type, and so the viscosity is constant on the shear rate. The thing that the structuring determines the change in the structure is visible from the shape of the viscosity curves that becomes pseudoplastic. Moreover, you can see in here in which the curve related to the 4.5% of waxes are represented in one, and the one at 5.5% on boxes represented by the triangle one. There is an increase on viscosity, increasing the wax concentration. And in some cases, there is a further increase when there is the fiber inclusion that are represented by the full solid, the black dots, basically. And what about texture? Our system were also analyzed on texture profile in a compression penetration system. The first, according to our results, the first result that we obtained, it was that confirmed our hypothesis that there was a higher compatibility with the sunflower oil of our waxes compared to the extra virgin olive oil. And higher was the concentration, better was the network resistance. Here in the bar chart, you have three bar charts. In the first one, there is the gel strength and the hardness expressed like Raptor force of our sample made of with sunflower oil with 5.5% of waxes, and with the addition of fiber at 25 and 0 degrees. This first bar chart highlights the detrimental effect that the cooling temperature has on our gel network. However, if you look down, you have the same quantity, so gel strength in red and in green, and the rupture force or hardness in purple, that were compared at three different temperatures for the control without fiber and the control with the addition of fiber at low granulometry. Lowest, that is the BF40. As you can see, again, you have a detrimental effect of temperature. And for the control, the test was fading out. So no results in terms of gel strength and hardness were collected. However, if you add the fiber inside the structure at a macroscopic level, you have an increase or a partial recovery. So you can hypothesize a counteractive positive effect of the fiber in the network. According from our last result, what we have done is to select some system, 8 systems finally, to re-prepare the gels and to include it in food metrics. In that step, even if the sunflower oil was were the ones with better results, we decided still for the food inclusion to maintain also the gel type. We prepared based on the butter cookies recipe, 3 control, one with the butter, and the other 2 control consider also the effect of the extra virgin olive oil and sunflower oil as such. And the other 8 systems were used for the preparation of the dough with the gel inclusion. Our first impression, our first understanding was that the inclusion of the gels give us the possibility to roll out easily the our dough, and then reduce the oiling out of our dough. But let's talk about the number and what about the texture. we carry out the test with texture analysis for both at both dough level and also at biscuit level. We perform a compression for the dough, and we perform two destructive tests of breaking in two different conditions, like penetration and then a bending test. What we obtain is that mainly the system with the gels as such gets more and more harder, both at dough level and at biscuit level. But if you substitute the gels itself with the gels reinforced with fiber, you can obtain in terms of firmness for the dough and in terms of hardness, so again the rupture force for the biscuits, values that are really similar to control. To conclude and to go to the final remark, oleogel is a potential solution as a fat replacement due to the versatile nature and the guarantee to maintain, to preserve the oil profile. Box oleogel are one of the solutions that are easier to scale up at the industrial level. And gel produced with different oils, however, show different affinity to the wax. Increasing wax concentration, also the structural property increase, and but the cooling temperature is a crucial parameter that has a detrimental effect on the network strength. However, fiber addition and low granulometry counteracts this weakening effect with a partial recovery of the network. And at biscuit level, both at pre and post baking, fiber gels show similar texture results to the butter control. I would like to thank you for your attention, and I'm more than welcome to ask your question.
Thank you very much, Laura. Very nice presentation. Very interesting presentation. Really complementary to the former one. So we have today very wide and look to the question of oleogels. Some questions for Laura.
I have a question here, Miguel from INL. Thank you, Laura, for your nice presentation. Very interesting. So how you see the use of waxes as a food additive or food ingredient? So they are in a positive list for some applications, but one of the problems that we see when we are using as a gelator in this kind of applications is the regulatory issues. How you are addressing that, or you are not thinking about this?
No, we are thinking about this, and for now, yes, we are aware that there are some limitations about the concentration of the use. Now we are trying to reduce the waxes concentration and to increase the fiber content to see what happens. This is our main goal. And another thing that we have to study, I told you there was the pandemic that, let's say that shuffle our plans, and to thinking about the partial substitution of the saturated fat. So in that case, if you partially substitute, you can decrease the concentration.
Okay, thank you.
More questions?
I have a question. Hi, Laura.
Hi.
Thank you for your very nice presentation. It's just a brief question regarding the texture results that you, or the texture parameters that you've used. When you used or you tested the texture of the oleogel, you tested different temperatures, right? Because of the storage.
I think that everyone is free. Okay, okay, now I can see you again.
So I will repeat my question. Are you listening?
Yes, I'm listening.
Why did you select different temperatures for the texture?
Yeah.
Texture tests that you performed with the oleogel, and was the Peltier of the texture analyzer at 0 degrees as well, or you just removed the oleogel from the room temperature?
The texture of the system were performed at room temperature, because our texture system doesn't have the Peltier system. So yes, after the preparation, after the storage, the system gets the ambient temperature, and when the temperature of our system was the same of the one outside, we performed the texture analysis. Unfortunately, we are not so provided with this. We have the Peltier system in the rheometer. Unfortunately, it's in the open air, the texture system.
Sure, just to make sure.
No.
Did you storage the dough for which period of time?
After preparation?
Yeah.
1 week.
1 week, okay.
1 week, yeah. Because we try also to do the day after, but we saw more variability between the tests. So we decided to give a little bit more time of for the storage, and yeah.
Okay. Thank you, Laura.
Thank you.
I don't know if someone else has some question for Laura.
Okay, I need to leave because I have another meeting now. Sorry, but you can keep here and to discuss more deeply if you want. So I let the administration role to Artur. Just to say thank you to Artur and Laura, and to remember that at the end of the month we will have another webinar. But keep here and discuss a little bit more if you need. Okay, ciao.
Ciao. So I don't know if someone else has some
Actually,
remarks.
in some minutes I have a phone call to make. I'm so sorry. Also, I thought there was at one from 1 to 2, but in Italy, so in Spain time zone, but sorry, in Portugal. So
okay. I think we can keep this just for a couple of minutes. I have a question here in the chat from Daniela. She's asking, since there were tests in different products like meat products and cookies, what would you say is the difficulties in both product types? So I will leave Laura answer first regarding cookies.
Because the butter substitution increase the hardness of the cookies. Basically, sorry, I have some headphones that sleep on my ear, and getting very, very tough. When you want to try the cookies, you want that also when you break it, they will not break it suddenly, but you can feel it. And this is, I think, this is one of the things that we can try to mimic, but we are not at the same level of the butter. And then then you have the problem of the oiling out at dough level when you are preparing after mixing, and when you are rolling, you have a lot of oiling out. That is partially limited by the substitution with the gels, but of course it's not the same with the basket control.
Okay, I can say that it was a little bit more challenging to use the wax-based gels in meats than the sterile-based ones, because they are much harder than the wax ones. Still, regarding the production of hamburgers, after cooking, the products that experimented increased the amount of oleogel incorporation, we can see, like Laura said, a little oil leakage. There is more evidence for the formulations with higher amount of gels, but still the sterile-based gels were a little bit easier to handle regarding meat-based formulations, because the matrices of these complex foods mingle well with these types of structures. So I don't know if there is some other question, or probably we can.
Artur, I'm
Hi.
Paco. Have you tested only vegetable oil to produce the oleogels, or have you tested another sources as fish oil, or maybe microalgae oil, or another kind of oil? Have you found different behavior of the oleogels?
Mainly, I've tested only vegetable oils. I've already performed some tests prior to this with some fish oil and algae sourced oil, but not to be incorporated in foods. Regarding the differences among oils, I've noticed that in terms of the ones that I've used, the oil phases like linseed oil or flaxseed oil, they don't produce gels, or they produce gels with different texture properties, as well as long chain triglycerides when compared with medium chain triglycerides. When we use waxes to gel these type of oils, there are some differences regarding the critical point of gelation. So we can gel the oil with a lesser amount of gelator, but those are very tiny differences, but that we've studied, but not experienced in the food formulation, new food formulations, because in that case we only used in this case we just use linseed oil and safflower. Yeah.
Okay, thank you.
Welcome. So I think this is it.
Yeah.
So I would like to thank you all for being here. Thank you, Laura, for your presentation.
Thank you.
Everyone, I don't know, I don't think that we will get another contribution from anyone. So I think we can close here this session.
Thank you very much.
Thank you, Artur.
Thank you for the presentation.
Okay.
Bye-bye.
Thank you.
Guys.
Bye.
Thank you.
Stay
Bye-bye.
safe.
Bye. Have a nice week.
Bye. Bye. Have a nice week.
Bye, Artur.
Bye.
Thank you.
Thank you.